Imagine a world powered by an endless, clean energy source, a modern-day sun created by human hands. China's artificial sun, a nuclear fusion reactor capable of reaching temperatures 5 times hotter than the core of the actual sun, promises to redefine the way humanity generates energy. But what if this technology, celebrated as a savior of our energy crisis, is also a harbinger of destruction? Could this be what Stephen Hawking warned us about when he said humanity's reliance on advanced technologies might lead to its end? China's artificial sun, officially known as the Experimental Advanced Superconducting Tokamak, EAST, is a marvel of human ingenuity. It aims to replicate the process that powers stars, nuclear fusion. Unlike nuclear fission, which splits atoms and generates hazardous waste, fusion combines atomic nuclei, creating vast amounts of energy without the same risks of radiation. It sounds like the ultimate solution to the world's energy problems: endless power with no carbon emissions or radioactive fallout, a dream come true. But there's a catch. The process of nuclear fusion requires unimaginable levels of heat and pressure, and the technology to sustain and control this power is still in its infancy. Critics warn that pushing the boundaries of energy production without fully understanding the consequences could be catastrophic. Hawking himself once said, "The development of full artificial intelligence could spell the end of the human race." While he was referring to AI, the principle applies. Our creations, if mishandled, could outpace our ability to control them. In 2022, China's artificial sun broke records by maintaining plasma at 70 million degrees Celsius for over 17 minutes. To put that into perspective, the core of our actual sun burns at around 15 million degrees Celsius. But this isn't just about breaking records. It's about scaling this technology to power entire nations. The potential is limitless, but so is the danger. What happens if the fusion process spirals out of control? Could an artificial sun become an artificial supernova? Stephen Hawking's warnings about humanity's reliance on dangerous technologies are hauntingly relevant. He argued that as our advancements grow, so do the risks. From nuclear weapons to AI, humanity has a history of creating tools that could destroy us. Fusion energy, despite its promise, could fall into the same category. A slight miscalculation, a failure in containment, or an act of sabotage could unleash an energy explosion beyond comprehension. But this isn't just a story about China's technological ambitions. It's about all of us. As energy demands skyrocket and fossil fuels drive the planet toward ecological collapse, humanity is desperate for solutions. Fusion energy could save billions of lives, but at what cost? Are we gambling with forces we don't fully understand? The artificial sun is a symbol of hope, but also of hubris. It represents humanity's relentless drive to conquer nature, to control the uncontrollable. But as Hawking warned, our greatest strengths can also be our greatest weaknesses. The question we must ask is this: have we created the key to our salvation or the trigger for our destruction? Imagine a force so powerful it can light up entire cities, power continents, and end humanity's reliance on fossil fuels. Now imagine that same force spiraling beyond control, consuming everything in its path. China's artificial sun, hailed as a breakthrough in nuclear fusion technology, embodies both promise and peril. But as we unlock this nearly godlike power, are we prepared for the consequences? Stephen Hawking's chilling warnings suggest we may not be. At its core, nuclear fusion is the process that powers the stars. The fusion of atomic nuclei releases vast amounts of energy, clean, efficient, and almost limitless. It sounds like the perfect solution to humanity's energy crisis. But achieving this on Earth is a monumental challenge. Fusion requires conditions so extreme, temperatures of over 100 million degrees Celsius, and unimaginable levels of pressure, that even the slightest misstep could lead to catastrophe. China's Experimental Advanced Superconducting Tokamak, EAST, has pushed these boundaries farther than anyone thought possible. In 2022, it maintained plasma at temperatures 5 times hotter than the sun's core for nearly 20 minutes. This wasn't just a scientific milestone. It was a declaration of technological supremacy. But the question lingers. What happens if this power goes wrong? Fusion energy promises a utopia. a world where energy is abundant, clean, and free from the geopolitical struggles that plague oil and gas. But the risks are just as profound. Fusion reactions require precise control. A failure in containment could result in a catastrophic release of energy, akin to a small star igniting on Earth. While proponents argue that fusion is inherently safer than fission, history has shown us that human error and technological failures are inevitable. Stephen Hawking warned that humanity's rapid advancements in technology could outpace our ability to manage them. His concern wasn't just about AI, but about all forms of extreme innovation. He feared that humanity's ambition, paired with its hubris, would lead us to flirt with forces we cannot fully understand or control. China's artificial sun embodies this duality. It's a testament to human ingenuity, but also a stark reminder of the dangers of pushing too far, too fast. The history of energy innovation is filled with examples of promise turning to peril. From the Chernobyl disaster to the Fukushima meltdown, the pursuit of energy has often come with devastating consequences. Nuclear fusion may not carry the same risks of radiation as fission, but it introduces new dangers. What happens if a fusion reactor becomes unstable? What safeguards exist to prevent the unimaginable? And who bears responsibility when things go wrong? China's artificial sun raises another troubling question: who controls this technology? While fusion could provide clean energy for billions, it could also become a tool of geopolitical power. Imagine a world where nations with fusion technology dictate terms to those without. The balance of power would shift dramatically, creating new tensions and potential conflicts. And what if this technology falls into the wrong hands? Could it be weaponized, turning an artificial sun into a weapon of mass destruction? But perhaps the most unsettling thought is this: even if fusion energy works perfectly, its existence could still doom us. Hawking warned that the easier energy becomes to produce, the more we risk exploiting it recklessly. Unlimited power might lead to unlimited consumption, accelerating environmental destruction in ways we can't yet imagine. Instead of saving humanity, fusion energy could hasten our downfall by removing the natural limits that currently restrain us. China's artificial sun is more than just a scientific project. It's a symbol of humanity's ambition and audacity. It represents our desire to control the forces of the universe, to bend nature to our will. But as Hawking cautioned, the line between control and chaos is razor thin. The closer we get to mastering these technologies, the greater the stakes become. Are we unlocking the secrets of the stars, or inviting a disaster of cosmic proportions? Imagine a star born on Earth, its immense power harnessed in a machine built by human hands. The promise of limitless, clean energy is tantalizing, but so are the dangers. China's artificial sun isn't just a technological marvel, it's a Pandora's box. Stephen Hawking's warnings about humanity's overreach echo louder than ever as we stand on the edge of an energy revolution. The question is no longer whether we can control this power, but what happens if we can't. The experimental advanced superconducting tokamak, EAST, is humanity's closest attempt to recreate the process that powers the universe. Fusion reactors like EAST use magnetic fields to contain plasma hotter than the core of the sun. This plasma, a seething, roiling mass of hydrogen nuclei, has the potential to unleash energy on a scale never before seen. But plasma is inherently unstable. If the magnetic fields fail, even momentarily, the consequences could be catastrophic. Fusion advocates argue that nuclear fusion is safer than fission. Unlike a fission reactor, which can melt down catastrophically as seen in Chernobyl or Fukushima, fusion reactions require precise conditions to sustain. If those conditions aren't met, the reaction simply stops. But simply stopping isn't as simple as it sounds. What happens if the containment fails while the plasma is at peak energy? A release of such heat and pressure, even for a fraction of a second, could result in explosions or fires on a scale we're not prepared to handle. Stephen Hawking warned that humanity's hubris, our belief that we can control forces far greater than ourselves, might be our undoing. He feared that as our technology advances, the risks multiply. Fusion technology may not be designed as a weapon, but its immense energy potential makes it a double-edged sword. In the wrong hands or under the wrong circumstances, a fusion reactor could become a catastrophic liability. But the risks don't end with containment. Fusion reactors require immense resources to build and maintain, from rare materials to highly skilled engineers. Countries racing to master this technology could create dangerous dependencies. Imagine a world where a single country controls the future of energy. Geopolitical tensions could escalate as nations vie for dominance over fusion technology. What was meant to unite humanity in a common purpose could become a source of division and conflict. There's also the question of long-term consequences. Fusion reactions may not produce the same radioactive waste as fission, but they aren't without byproducts. Tritium, a key component in fusion, is radioactive and difficult to contain. Over time, even small leaks could pose environmental and health risks. And what about the reactors themselves? Decommissioning a fusion reactor could take decades and cost billions. Are we prepared to manage the waste left behind by our artificial suns? Hawking's warnings feel prophetic as we consider the sheer audacity of creating a star on Earth. He argued that humanity often advances faster than it can comprehend the consequences. We've seen this play out before. Nuclear weapons, industrial pollution, and AI are all examples of technologies that outpaced our ability to manage them responsibly. Fusion energy, with its promise of near-limitless power, might be the ultimate example. The most chilling part of Hawking's warning is that we might not realize the danger until it's too late. Fusion reactions are complex, operating on principles that even experts don't fully understand. Small errors or oversights could have cascading effects. A tiny flaw in the design of a reactor, a miscalculation in a containment field, or even an act of sabotage could unleash forces beyond our control. China's artificial sun represents both the pinnacle of human achievement and the precipice of disaster. It's a symbol of our desire to master the universe, but also a reminder of how little we truly understand it. Hawking believed that humanity's survival depends on our ability to balance ambition with caution. But are we capable of that balance? Or will our pursuit of power push us past the point of no return? What happens when humanity plays with the forces of creation and loses control? The artificial sun burns brighter than ever. Humanity stands on the verge of an energy revolution that could solve our greatest challenges: poverty, climate change, and resource scarcity. But Stephen Hawking's dire warnings linger in the shadows. As China's artificial sun project continues to break records, one question remains: is this humanity's salvation, or the spark that ignites its destruction? For decades, nuclear fusion has been seen as the ultimate energy source, a clean, limitless solution that could power the world for millennia. China's artificial sun is at the forefront of this effort, a shining beacon of hope for a planet desperately seeking alternatives to fossil fuels. But as we marvel at the technological achievements behind this project, we must confront the uncomfortable truth. Power this immense comes with risks we may not be able to contain. Fusion's promise is almost too good to resist. Unlike fission, it produces no long-lived radioactive waste and carries no risk of meltdown, at least in theory. But critics argue that this optimism overlooks the practical realities of managing plasma at over 100 million degrees Celsius. The challenges of containment, resource extraction, and long-term sustainability remain daunting. Even a minor miscalculation could lead to catastrophic consequences. Hawking's warnings about humanity's blind reliance on advanced technologies feel more relevant than ever. Hawking famously said that humanity's survival depends on caution. He feared that our ambition to harness forces we don't fully understand could outstrip our ability to control them. The artificial sun embodies this paradox, a symbol of human ingenuity, yet also a stark reminder of our hubris. The very act of creating a star on Earth challenges the natural order. Are we prepared for what happens if we push this technology too far? There's another layer to this dilemma, one that extends beyond science. Who controls this power? Fusion technology could reshape the global balance of power, creating energy independence for some nations while leaving others behind. What happens when the nations that perfect fusion technology dictate terms to those that don't? The artificial sun, instead of uniting humanity, could deepen divides, sparking geopolitical tensions over resources, patents, and intellectual property. And then there's the question of ethics. Fusion reactors like China's artificial sun require massive amounts of money, resources, and expertise to build. As we pour billions into these projects, are we ignoring more immediate solutions to the world's energy crisis? Solar, wind, and geothermal technologies already exist, yet they remain underfunded compared to fusion. Are we gambling humanity's future on a technology that may never be fully realized, while neglecting the tools we already have? The most haunting part of Hawking's prophecy is his belief that humanity often fails to foresee the long-term consequences of its actions. The artificial sun is a marvel, but what if it becomes a symbol of humanity's greatest flaw, our inability to balance ambition with caution? What if our quest to solve one crisis creates another, even more devastating one? Yet amidst the risks, there is hope. Fusion energy, if perfected, could power the world without destroying it. It could replace fossil fuels, halt climate change, and lift billions out of poverty. It could redefine what's possible for humanity. But for this dream to become a reality, the world must proceed with caution, collaboration, and an unwavering commitment to safety. Hawking's warnings were not meant to stifle progress, but to guide it. As the artificial sun rises, the choice is ours. Will we use this technology to unite humanity, or will it become another tool of division and destruction? Can we harness this power responsibly, or will it spiral beyond our control? These questions aren't just about China's artificial sun. They're about humanity's future. Before you leave, think about what's at stake. The artificial sun represents more than just energy. It represents the kind of world we want to create. Will we build a future of light, or will we burn ourselves in its pursuit? Share your thoughts in the comments, subscribe to stay informed, and turn on notifications to join the conversation about this pivotal moment in human history. The sun has risen, but will it illuminate our future or incinerate it?